Okay, so now we're going to talk about finding infinite limits. So when we're finding infinite limits, we can do this numerically. We can also find the infinite limits if we know what a parent function looks like. So I'm going to quickly go over with you what a couple of important parent functions are. One important parent function that you might have learned a long time ago is y equals 1 over x. And it just looks something like that. That's not extremely accurate. This point would be right here. Make the point big enough. There you go. There you go. Awesome. So that's one function. And then, of course, you've got your transformations. You reflect over the x-axis. You reflect over the y-axis. You've got your translations going left, right, up, down. But it's all about that parent function and knowing the behavior of that parent function. Then we've got one that you might not be familiar with. And I honestly don't know why we don't teach this one more often than not, but this one is y equals 1 over x squared. And then, of course, you can reflect. When you make it a negative, it's going to reflect so that both ends are doing the same thing, going down towards negative infinity. I'm going to erase that because it's really about the ends doing the same thing. Degree 2. Isn't that interesting? But it's not really a degree 2 because it's not a polynomial. It is y equals 1 over x squared. So let's talk about infinite limits. So we've got the limit as x approaches 1 from the left. 1 over x minus 1. One way I can do this is by making a graph. And then the other way we can do this is numerically. That's kind of a lousy there. Oh my gosh, look at that. That's beautiful. Okay, we have a shift going right 1. So that vertical asymptote is going to be at x equals 1. And this is the parent function, y equals 1 over x. So we've got this happening. So 1 from the left, let's do this in green. 1 from the left is going to be approaching 1 from the left side of 1, and what's happening to the function? That function is approaching negative infinity. So the function value is approaching negative infinity. Now how can we do this numerically? Well, because we have a vertical asymptote at x equals 1, and because we can recognize that we have a vertical asymptote at x equals 1, we're not talking about the point of discontinuity of the whole. We're talking about the point of discontinuity that's the vertical asymptote now. When you have that point of discontinuity that results in a vertical asymptote, you can't substitute in your 1 ever because it's not going to go away. There's no way to get rid of x minus 1 in the denominator. So if we put a value to the left of 1, let's say 0.9, that's going to tell us what's happening at that vertical asymptote of x equals 1. So that would be 1 over negative 1/10, and 1 divided by negative 1/10 is negative 10. And if I got even closer, maybe said 0.99, I would have 1 over negative 1 over 100, and then that would be negative 100. So the closer we get to 1, the larger our value gets in the negative direction. Now, if you already know that you have a vertical asymptote at x equals 1, you're just looking to see whether or not your sign is positive or negative. And this number right here was a negative, so that tells us negative infinity. Okay, let's try from the right-hand side. Now, we already know from the right-hand side what's happening because I have the graph drawn already. Right? We already know that our answer is going to be positive infinity. But let's put a number in. So from the right-hand side of 1, we might be talking about 1 over 1.1 minus 1. So from the right-hand side of 1, we might have 1.1. That's 1 divided by 1/10. 1.1 minus 1 is 1/10. And 1 divided by 1/10 is 10. And that's a positive 10. So So that's going to give us a positive infinity. Now, how did we go from positive 10 to positive infinity? That's because we know that there's a vertical asymptote at x equals 1. And what happens at your vertical asymptotes? Your graph is hugging it, I like to say hugging it, going up, or perhaps hugging it, going down towards negative infinity. It could be hugging it from the left-hand side, going down towards negative infinity, and hugging it from the right-hand side, going up to positive infinity. In either case, these are limits that are infinite limits. Okay, what's happening here? Let's try this numerically. We know we have a vertical asymptote at x equals 1. So from the left side of 1, this is from the left side of 1, we're going to have 0.9. I like to just use a tenth. So I'm going to have negative 1 over 0.9 minus 1. That's negative 1 over negative 1/10. A negative over a negative is a positive, and 1 divided by 1/10 is 10. So that's a positive value, positive. That's going to be positive infinity, because we always approach our vertical asymptotes from the left or right, number one, and our outputs at that vertical asymptote are values of infinity. So whether it's negative infinity or positive infinity. So what's happening from the right-hand side? Well, the right-hand side, I would put a 1.1 in. So that would give me negative 1 divided by positive 1/10 is negative 10. This would be negative infinity. So I've shown you two ways to do this. One using a graph and knowing your parent functions, and the other using numerical values from the left-hand side, from the right-hand side. Now, what happens if I say, let me just go back here real quick. Let's look at this right here. Let's look at these right here. I'm going to erase that pink, but that's what I want you to look at, because it's the same function. One is approaching x from the left of 1, and the other value of x that we're approaching is from the right of 1. Those two values are not the same. Negative infinity is not the same as positive infinity. Negative infinity is not the same as positive infinity. Our ends are doing different things. Therefore, the limit as x approaches 1 of 1 over x minus 1 does not exist. And why does it not exist? Because the ends are doing different things. Different things. I'm going to keep that pink there. No, I'm going to erase it. There. Yeah, I'm going to erase that one too. There. Nice and clean. So let's try these four. Matter of fact, you try them. You can either use the graph, because I already gave you the parent function, or you can plug values in and see what happens. Plug values in and see what happens. When you come back, I'm going to provide the answers. Okay, here are our answers. We've got a positive infinity. The limit as x approaches 1 from the right of that same function is also positive infinity. Our limit for the next approaching 1 from the left is negative infinity, and that same function approaching 1 from the right is also negative infinity. So if you got those answers, you are on the right track. So what we're going to do in the next video is we're going to talk about finding vertical asymptotes, determining infinite limits. So finding vertical asymptotes and determining infinite limits.